Alright, so I'm going to show you how to solve this problem. It reads 8 identical point charges of QC each are located at the corners of a cube of side length A with one charge at the origin and with the three nearest charges at A00, 0A0, and 00A. We are tasked to find the expression for the total vector force on the charge at point AAA, assuming free space. So this is just simply finding the net force acting upon a single charge. So since there are 8 identical point charges, so we need to find 8, I mean 7 force equations, but there's actually an easier way because each of them are identical. But first, let us find the coordinates of the 5 other locations of the charges by drawing a cube. I've already drawn a cube. Not really a great artist, but here it is. I've already plotted out the coordinates of the locations of the other charges. It's actually quite easy because each of them just have a side length of a. So here's at the origin, at the 000, and this is the charge in question. So each corner has a charge that are acting upon the charge right here. So but first, let's find their distances, and let's also find their respective unit vectors. So let's start with the easy ones, the ones with the double a's in them. Okay, let's start with P2D. Okay, number 1, RPD. So since both of them has two A's right here, that means all that will remain is A. So we have AX and the unit vector is simply AX. Now we go to number 2. Let's use this since the y component is missing. So if we subtract this from the point A, we're just left with a y. Okay, R P E is equal to a y, and the unit vector is simply a y. Now we go to number 3. Number 3, where here both the x and y components are there, but the z is not. So subtracting this charge point F from point P, we got RPF. All that's left is AZ. APF is AZ. So far, so good. Now let's go over to points with just a single A. Okay, how about let's do this first. R from point P to C. So since only the Z coordinate here is available, so if we subtract this from point P, we're left with a x plus a y, and the unit vector is ax. APF is equal to ax plus ay over square root of 2. Now let's go to the next one. Single A, we've already done C. Let's do this. RPA. RPA. So since the A is present here, if we subtract this from point P, we are left with AY plus AZ, then APA the unit vector. So we should be left with ay plus az, of course, and still the same. Divide them by square root of 2 so we can find the unit vector. Now let's go to number 6. Okay, number 6 right here. Since the ax and y, ay, and az is already given, so we got A, we got C. What else did I not do? Oh, I didn't do B. So RPB, since the Y is present, subtracting point B from point A, we get X and Z only. So AX plus AZ, and the unit vector is AY, no, not AY, X plus AZ all over square root of 2. And lastly, from point P to the origin, let's write that down as RP, then O for origin. So since all of them are zeros, so it's simply AX plus AY. That doesn't look like a Y to me. AY plus AZ. And the unit vector, APO, is AX plus AY plus AZ. Divide them by the square root of 3 so we can find the unit vector. So here are the distances and the unit vector. So before we proceed, let's combine 4, 5, and 6 together. So it won't be that confusing. So for the axis, so we got 2 of them. So we got let's put that here, 1 over 2, 2ax, and then 2ay's plus 2ay's, and then 2az's. 2az's. So you can just say 4, 5, and 6 are 2 over root 2 ax plus ay plus az. Okay, so what are we going to do next? It's simple. Let me just zoom out a bit. And yeah, let me just zoom out a bit right here. So let me write everything here. I hope you can still see it. Since all of them are identical, acting on point P, so we can just simply put q squared 4 pi e sub naught. So since we already got everything right here, we got the unit vectors, and we also got the distances. Let's put all the denominators, let's raise them to the power of 3 each. Okay, let's start with putting all of these together. AX plus AY plus AZ. Now let's put this plus 2, 2, 3 AX plus AY plus AZ. Then let's put this here plus 1 root 3 AX 3AX plus AY plus AZ. Now from here we can just factor everything out, so it'll be easier. So it should look like this. So equals to q squared 4 pi e sub naught. So we got the 2 right here. And also we got this. We also have this. If we group them all together, Their factors are 1 plus 1 multiplied by ax plus ay plus az. Let's add this together. Let me just go ahead and use a calculator. 1 over root 2 to, no, this shouldn't be squared. I'm sorry, this should be cubed. Cubed plus 1 over root 3 cubed plus 1. And we got the answer to this is 1.8995, but let's put this as 1.9 so it'll be easier for us. So we have 1.9 q squared. We get the force of 1.9 q squared 4 pi E sub naught, the permittivity of free space, multiplied by quantity of ax, ay, plus az. So this is the expression for total vector charge at point P. Now, if we want to find the magnitude, this is simple. It is like this: 3.29 q squared over 4 pi E sub naught. Now, if you want to ask why it's 3.29, so remember, we already have a 1.9 right here. Let's, if you want to find a magnitude here, so this is going to be root 3, right? So root 3 times 1.9, that is equal to root 3 times 1.9, that is equal to the number right here. And yes, I hope this helps. So let me just zoom out so you can have the full picture right here.